prediction of car price using linear regression. We will having a data set that has the information about the used cars, and we have to predict the resale value of those price. First of all, we will import the libraries pandas, numpy, and matplotlib. Now we'll read the data into a data frame using readcsv, pd.readcsv command. Here I have this car data. I have saved here. This data set, it will be available. I'll put its name here. Okay, it's done. So df.head will print the first five columns, first five values of the data frame. df.shape, so we have 301 values of 9 columns. df.size, it will give the total number of elements, that is the multiplication of these two of rows and columns. Now df.info will give a quick idea about the type of total number of columns, total number of features that we have, and the data type of those features. Here we see that we have 3 object types, 4 object type features, and rest are integer or float types. Now we'll check for the null values. To check for the null values, we will be using df.isNull. This will give us false and true values. If the values are true, if it is a null value, it will give a true, otherwise it will give a false. So adding a sum in front of that is null, it will give us the sum of total number of null values. As we can see, the total sum is 0, so we have no null values here. Now moving on to the next step, we'll drop the car name because it is not really contributing to our machine learning model. Means we are not really getting, like mathematical model, we are not getting any information from the car name. That machine is not getting any information. So we'll use df.drop car underscore name axis equal to 1. Axis equal to 1 means that we have to drop the name in column wise. By default, the axis is equal to 0. That is row wise. In place equals to true, it means that you work on me only. The data set is saying that you make the changes on that data frame itself. So for that we use in place equal to true. So here we see that our column is dropped. Now we want to find the age of the car, how many years old the car is. So for that we will use a simple formula that the age of the car will be the present year minus the year in which it was purchased or in which it was manufactured, anything. So for this, first what we'll do, we'll make a column in the data frame named as current year. That current year will have the value 2023. In all the values will be 2023. So df of current year equals to 2023. Now see here we have a new column here with all the values at 2023. Now the age of the car I'll make as a new column. So df of car age is equals to df of current year minus df of selling price. Df of selling price means it is using that column data frame, means selling price column of that data frame. Sorry, year column of that data frame. So here we see that we got our column as car age. Now we'll drop the year and the current year columns. Again using df.drop function. df.drop. The columns that we have to drop, we'll put them as list. Year, comma, current year. Again, we have to specify the axis that it is to be dropped against columns, and in place equals to true. Axis equals to 1. Okay, I seem to have made some. Okay, true. T should be capital here. T should be capital here. In place equals to true. So let's check out our data frame now. So we have the year and current year columns are dropped. Now let's check the info again. So now we have to deal with the columns that are of object type. These are objects, so they can have any values. And since we have imported it from Excel, we know that these are texts. Further, I can visually looking at it, I can see that they are of categorical type. Categorical means either it will be dealer, for example, in transmission type, either it will be manual or automatic. Owner, it will be either dealer or own used, something like that. So for that, for these categorical values, we have to create dummies. So df equals to pd.getDummies, df drop underscore first equals to true. So here we see that the categorical values have been converted into int type, integer type. Drop underscore first is used to drop the first value because, for example, in fuel type diesel, if we see, if it is 0, if it is 1, we know that the fuel type is diesel. If it is 0, we automatically know that fuel type will be petrol. Now first we will split our data set. Now we will take X and Y. So X will be our data frame that will be contain the features, and Y will be the data frame that will contain our target. In our case, our target feature is the selling price. We have to predict the selling price. So for that, we will drop the sorry. Selling price is the price at which okay, let us assume that we have to predict the present price. So we have dropped the present price in X and we have used that present price in Y. So present price is our target variable for now. Now we will split this X and Y into training dataset and testing dataset. So we will use 80% of the data for training and 28% of the data for testing. So for that, I have imported train test split from sklearn.model selection. So x underscore train, x underscore test, y underscore train, y underscore test will be train test split, and I'll put x and y. random underscore state equals to any number we can put here. This will ensure that randomly only those values are selected. It will freeze those random values. And test underscore size. Let's print the size of our train and test data frames that have been created. Okay, I seem to have made some mistakes. Okay, I'll copy paste the commands. That's better. So we have 281 in train and 20 in test. 20 in test. Where are we getting 20? Just a minute. I will try to change it to 30. Okay, it changed to 30. Okay. I seem to have made a mistake here. I cannot use 30 here. I have to use 0.3 or 0.2. 30 means it is absolutely using absolute 30 values. It got 30 values out of it. 0.2 means 0.2 or 0.3. It means it will be using 20% of the total data frame, total features, total number of instances. 0.2 or 0.3. If we use 0.3, it will be 30%. Okay. So here we had made a mistake of putting test size as 20. That's the reason it was only using 20 values for test. We don't want that. We want 20% of the instances, 20% of the cases. Okay, moving ahead. Now we will apply linear regression on these data frames to get our predictions. So first we will import linear regression from linear underscore model. From sklearn.linear_model, I have to import linear regression. Then I have to make an object. LR is my object. So LR is equals to linear regression and function. Linear regression. Okay. And now I will fit my data on this object. First I imported linear regression. I made an object of it. And on this object I'll have fit my x and y. So it is done. It is completed. Now I will check my predictions. So y underscore prediction for the test values. So for the test values, I will put x underscore test. lr dot predict. lr is the object. Object dot predict y underscore test. sorry, x underscore test. It will not be y underscore test. Yeah. So we have one predicted values and we have y actual values. These are the predictions. This is the predictions that our model has done on the test dataset. The test features were fed to the data and it gave me the y, means the predicted data. This I have to compare it with my actual values of the test data, that is y underscore test, and then I have to check how much error is there. In this particular video, we have just we have tried to keep the things very simple and very basic. It is the basic program in the basic level. We have not added much complexity. So we'll just check the error and leave it as it is. So from sklearn.metrics import mean squared error, and MSE, which is mean squared error, this is this will be calculated on y underscore test and y underscore prediction, that is our tested value and predicted value of the test data set. And then we'll do the square root of it to get the root mean square error. Root mean square error is the metrics that we use to evaluate our model, that how it is functioning, usually to evaluate it and to compare it. Okay, so that's all for this video.